Since we have discussed so much about collision and explosion as well, this next topic is just sticking to collision. Let me fix my pen. Yeah, so this topic is fixed to collision only. When we talk about collisions, collisions can be of two types: elastic collisions and inelastic collision. Now, the difference is very simple because in an exam, if you have seen the past paper, there might be questions where they ask you, state what you mean by elastic collision. So here, kinetic energy is conserved. So in a collision, if the kinetic energy is conserved, that collision is called as elastic collision. And kinetic energy is not conserved, that means it's an inelastic collision. Now, what do you mean by conserved? Conserved means kinetic energy initially is equal to kinetic energy final. So before the collision, whatever the kinetic energy the system had will be equal to the kinetic energy the system has after the collision. And in this case, kinetic energy initial will not be equal to kinetic energy final. As simple as that. Now let's take a scenario. Let's consider a system where of two bodies. Body with mass m1 is moving with velocity u1, and body with mass m2 is moving with velocity u2. After the collision, the body with mass m1 will move with velocity v1, and the body with mass m2 will move with a velocity v2. Now here, to figure out whether this collision that happened right now is an elastic or inelastic, you have to figure out total kinetic energy of the system initially and the kinetic energy of the system, total kinetic energy of the system final. Now, we know that the formula for kinetic energy is half m1 u1 square plus half m2 u2 square, and here it would be half m1 v1 square plus half m2 v2 square. Once you figure out the kinetic energy, the unit of kinetic energy is joule. Again, I'm repeating, it's very important. If you're measuring some quantity, you should mention the unit. So the unit is joules, which is indicated by letter J, capital J. So here, if your initial kinetic energy of the system was equal to final kinetic energy of the system, then it is a elastic collision. As simple as that. And if this initial kinetic energy of a system is not equal to the initial kinetic energy after the collision of the system, it is inelastic. Now the question arises, if it is elastic, that means no energy is lost, energy is conserved. But if it is inelastic, energy is lost. So when I say lost, that means it is converted from one form to another. That means this kinetic energy that is lost, it can be converted into sound energy or heat energy because of friction. So in your exam, if it is an elastic collision, you don't have to worry about it. You figured out the initial kinetic energy, you figure out final kinetic energy, they both will be equal, problem solved. Or if they say that the collision is elastic, you can use this thing to figure out some velocity or something. But that's not a correct way to do it. The correct way to figure out the velocity of an object is using conservation of momentum, because remember that even if it's elastic or inelastic, your conservation of momentum always apply. That means your sum of initial momentum will be equal to sum of final momentum, irrespective of whether this is elastic or inelastic. This is always true. Just remember that. So if they give you some kind of collision and they are asking you, so you can use that. But what happens in the question, they might say that this is an elastic collision, and how much energy is lost in friction. And if they say that, that means that initially whatever the kinetic energy it was there, if it is not equal, that means some of it is converted into friction. Now we have to assume, they will say that in the question, that assume that sound no other form of energy is there in the system, only friction is there, because of which the heat is there. So they will give the scenario. But remember that if it is an inelastic collision, kinetic energy that we have is converted into some other form. It can be sound, it can be heat, it can be any other form which they give in the exam. And to figure out which form it is, I can say that kinetic energy initially, sum of kinetic energy initial will be equal to sum of kinetic energy final plus some x amount of energy. We don't know what is this energy. This is the case for an inelastic collision. If it is an elastic collision, obviously there is nothing lost, there is no other form, it's all kinetic, kinetic, kinetic. So this is the thing. Apart from that, there is something called as perfectly inelastic collision. Now this is a special case, perfectly inelastic collision. When I say perfectly inelastic collision, in this collision what happens is that, suppose you have a body with mass m1 moving with velocity u1, body with mass m2 moving with velocity u2. They collide and they stick together. When they stick together, they move with velocity v, and their individual velocity m1 m2 is there. Now in this case, here we know that the kinetic energy, it's an inelastic collision, there will be loss of kinetic energy. This is where the maximum loss is happening. Maximum loss of kinetic energy is there. So you can figure out how much is lost, but we can apply conservation of momentum as well. We know that. So it will be m1 u1 plus m2 u2 is equal to m1 v plus m2 v, and we can treat these we mathematically we can take v common, and I'll get m1 plus m2 times v. I'm applying conservation of law of momentum, and this will help you to understand what will be the final velocity, and this will give you something such as m1 u1 plus m2 u2 upon m1 plus m2. This is the scenario where your maximum kinetic energy is lost. This is perfectly inelastic collision where the body stick together. Remember that if the body is sticking together, this is the thing. So if the body is sticking together, you have to consider them as a combined mass. So you just add their mass and treat them as a one body. So m1 m2 plus, and then you have the velocity v. So this is the case. So remember that elastic collision, kinetic energy is conserved, initial is equal to final. Inelastic collision, kinetic energy initial is equal to kinetic energy final. Now the question arises, if the collision is in 2 dimension, what should we do? Good question. Let's consider a simple scenario. m1 u1, I'll keep it very simple, m2 with u2 is equal to 0, a very simple scenario. And after collision, there is m1 which is going with velocity, there is m2 which is going with velocity. Now to figure out whether this is elastic, inelastic, first of all, very simply you should know v1, and you should know v2. That's it. Now in your exam it might happen that you have to find out v1 and v2 on your own, or you have to find out v2. There can be a case where it can be figured out using resolution of vector and conservation of momentum, but you just have to know v1 and v2, and then you'd use the simple kinetic sum of kinetic energy initial, that is half mv square u1, half m1 u1 square, and half m2 u2. squared and xyz on both the side initially and finally, and you will come to the scenario. Now what happens is that uh, in your exam, if there is a case, okay, and they're asking you figure out whether this is elastic or inelastic collision, we should not use the formula of kinetic energy as half m1 u1 square, because we have to figure out this v2 for an example. That means we have to initially use the formula for momentum, p is equal to mv. We have to use the formula. So don't stick to this formula. We have a formula for kinetic energy which is something as p square upon 2m. We use this formula. Stick to this formula, p square upon 2m. Don't stick to half m1 u1. So so now question can be how do we get this formula? It's very simple. The formula is half mv square, and if I just multiply and divide by m, v square upon m into m. Now we know that I'm not changing the ratio, so here I'll get m into m will become m square, so I'll get half m square v square upon m, and this gives you half mv the whole square, and mv is nothing but momentum, that is p square upon m, and this can be simply written as p square upon 2m. So this is the formula we use. Ek is equal to p square upon 2m. This is the formula. So where to use? Now if there is a collision happening and you have to figure out some velocity initially, and then you have to figure out whether it is elastic, inelastic, then we'll use this formula. Thank you so much. That's all about elastic and inelastic collision.